In this workshop, our speakers will dive into the extended and updated 15 factors needed to build cloud-native applications that are able to thrive in this environment, and get hands-on with open-source technologies and tools that can help us achieve this. Everyone, please give a warm welcome to IBM architect and developer advocate, Mr. YK Chong, and joined by IBM software developer and developer advocate, Mr. Rich Haggarty.
Hi everyone, glad to be here and thank you for giving me a chance for us to talk to you all at SoftCon 2023. So it's excited to be here. I'm YK and with me is Rich.
Hello.
So let me share what we have and then we will get going here. All right, so we have a workshop here today, Thriving in the Cloud, Venturing Beyond the 12 Factors. So it's a hands-on workshop that Rich and I will deliver to you all, and we invite you to follow along and join us on the journey, right? A bit of an introduction first. Again, I'm YK, and with me is Rich. We're both developer advocates from IBM, and we are from our application runtimes team that covers all our cloud-native Java technologies, from the core Java SDK to our cloud-native Java framework in Liberty or our long-time enterprise great platform in WebSphere, and to all the latest innovations that we have around cloud-native Java technologies. I'm currently based in Malaysia. I was in Canada. I am in Malaysia for a few years now. For a few years this period. And Rich is joining us from US, Texas. So our plan for today is that we have 2 hours. It's a hands-on workshop. We'll do a bit of introduction and level setting to give you all the context of what we're looking at here, and then we'll go into some hands-on labs actually that we invite you all to come along. It's pretty easy to follow along, right? We are going to use a cloud-hosted environment, so there's really no much of a setup required, and we'll be doing a few labs together if that's all right, and we invite you all to come along. We'll be taking you all through it step by step. Obviously, you're invited to go as fast as you would like, or you can just stick with us, right, as we proceed here. So that's the plan. And let's take a look at the topic of the day first, right? And 12 factors, 15 factors, and how they relate to cloud-native Java applications, and what are some of the technologies, especially open source technologies, that are available to help us with that. Now, if you have any questions as we go along, feel free to put them in the chat, and then we'll try to address them, right? So don't hesitate to interact with us anytime. So cloud is really the thing these days, right? It's been for quite some time now, and it continues to be the focus for the industry. And I don't know what comes to mind when you think of cloud, right? Perhaps many things comes to mind, including blue sky, sunny days, and things like that. But if you look at it from a technology standpoint, you ask different industry practitioners, any one of us, right? So you might get many different keywords or descriptions. For instance, cloud will give you scalability. It makes it easier for you to scale, and you can do rapid deployments. Your services will be loosely coupled where you can easily update them or scale them up or take them down, and then you will achieve resiliency with cloud, and you can have speed of deployments or being able to bring new innovations, new applications, new services to your users or customers at a faster speed, right? You may be working with public clouds, different form of clouds, whether it's on premises, private, public, hybrid, or you may be running your own. You may be doing software as a services or platform as a services, all sorts of things, right? So there are all these things. Now, is there a way for us to help us think about cloud, especially from an application or application deployment standpoint? And that's where the 12-factor application methodology comes in, right? The 12-factor app. You all may be familiar with it, right? It's been out there for some time now. If you go to the 12factor.net, you'll get the treatise about it there, right? It's really a way to help us think about what it means to build and deploy and run web applications or modern cloud services these days, right? So what are some of the key characteristics summarized in 12 factors that we should consider as we think about creating the next application for cloud or writing the next microservices for cloud, right? And then what we're building and what we're running, are they good enough, right, so to speak, right? It's about how you can have clean contracts between your systems, right, and how you can maximize portability and make it easier for you to deploy in cloud environments, and not only just one, but perhaps move your application across different environments, right? So 12 of these factors come together to help us think about what would be some of the good practices to consider when it comes to cloud applications, right? So I'll quickly give you all some examples of them, right? I won't go over in all details the 12 factors. You can read about them out there, right, at 12factor.net, right? So there's code base, dependencies, configuration, backing services, build, release, run, processes, port binding, concurrency, disposability, depth, prop, priority, locks, and admin processes, right? Some of these are obvious, right? For instance, code base is about having version control for your code. You have your one main repository for your source code, right? That's version control, and then you build everything from there. Your source code becomes your main source of information, right? So that's code base, right? And some of it is about from a programming standpoint, it's pretty obvious, right? So dependencies, we need to be able to know about our dependencies, being able to declare them, right? Do declarative dependencies, be able to isolate them and manage them easier. And then, for instance, configuration comes down to not hard coding, right? Externalizing your configuration, have your configuration as part of the environment, right? How your application, when it comes to deployment, how things will be configured is actually a function of the deployment environment as opposed to your code, while your code will work with different configuration parameters, but the actual values of the configuration should come from the actual deployment environments, right, will be provided at runtime or deploy time. So that's what configuration is about. For instance, build, release, runs goes back to code base. Once you have your code, your SVN or version control system, right? So then you would have good, it calls for good CI and CD, continuous integration and continuous deployment practices, so you can build, release, and run, right? So they will be distinct build phases, and then you would have your release processes automated, obviously, and then you'll be able to deploy and run your applications, right? And other aspects, like, for instance, concurrency, disposability, or even processes or port binding maps to how we can easily scale our applications and up and down, right? So processes talks about being stateless, right? And concurrency speaks to being able to scale up easily, right? You can bring in new instances of your applications when you need to. Disposability calls for being able to bring down your application or your instances easily, gracefully, and be able to bring up new ones faster, right? That priority goes back to CI/CD too, where you have consistency and parity between your deployment environments and production environments, because that's really what continuous delivery is about, right? You want to build and test what you are going to deploy without differences. That makes it easier when it gets to actual production deployment, that things are the same across all your environments, and then you would be able to not only figure out problems earlier, sooner, and then you don't have to worry about differences between your environments, right? So these are some of the 12 factors that's there, and then that helps us to think about how to write good microservices or cloud native applications, right? Now, after the 12 factors, there comes the 15th factor, right? So there is additional 3 factors that have been introduced given the advent of things, how the industries has evolved and more knowledge has been built around the topic, right? So it's based on the 12 factor, but there is additional considerations, right? And the 3 primary considerations would be around the 3 new factors, if we will be around API first, telemetry, and authentication authorization. And that's what we'll try to focus on today, especially with our hands-on exercises to show you all how these things can be easily considered with modern Java APIs, right? API first is about obviously using APIs as your contract between your services, right? So imagine you have your RESTful services, right? Then you have defined RESTful APIs between them, and then your services will interact with each other with through well-known and defined contracts, right? So let's think about defining your APIs first. So that's the API first new 3 factors have been added or introduced. And then there's telemetry. Telemetry is about being able to observe what you have deployed in your environment, not only your services, but essentially your environment in an easy manner so that you know what's going on, whether your applications are running fine, they are healthy, or they need there are issues going on. You'll be able to understand what's going on and even go to the extent that you can trace through your distributed environments in an easier manner, right? So that's telemetry. And then authentication and authorizations, they're pretty straightforward. That's really about security, right? Security cannot be an afterthought, even in the cloud, especially in a cloud environment, right? So you have to think about it first. If you need to move across environments and things like that, that cannot be an afterthought. It has to be think about and consider first and built in, right, into your architecture, and then that makes it easier for you to achieve secure deployment. So let's try to translate these terms or these factors into something more visual to help us think about how they can help us achieve good deployments, right, good cloud native applications, right? So this is a view of just a pictorial representation of a potential deployment that you have, right? So you would have your, obviously coming in, you have your source code from the left. Imagine you have your source code from there, your applications, and then you have different repositories that you work with. Obviously, you have your source repository. Besides that, you may have your binary repositories for your artifacts, or even these days for your container images, right? So you have your image repositories, and these things would then be fed or be brought down into an actual deployment environment through your CI/CD process, right? So you have your application running in the cloud, whether it's private or public or a mix of that. And then you have your services that would back your different applications, right? So this is the backdrop or the environment or the picture to keep in mind. Then let's bring in the factors, right? So as you can see, we start off with the code base, right? So coming in from the code base, you have a good CI/CD process to helps you to go from design, build, release, and run, right? And then making sure that you have parity between your environments, right? So as you create and stand up different environments, whether it's for development purposes or for testing purposes or pre-production validations into productions, you want to ensure that they are consistent across, right, the different stages of your deployments. And then feeding into that, right, you can see when it comes to your application itself, you want to achieve stateless, you want to achieve concurrency for scalability, making sure that it's easily disposable or new ones can be brought out easily, right? And then it's sort of this backing services will be easily attached, right? As it interacts with other applications, you would access it through port binding, but basically, through port binding, and then configurations will be externalized to the environments, right? You may be using different clouds or whatnot. Then your configurations will be defined through the environment, and then the applications can pick them up without code changes, right? And then admin processes will be separated from your application itself, right? For instance, if you're using Kubernetes, obviously how you would administer your applications is already by definition separate, right? So then you think about telemetry, authentication, your environment should support your apps to be observable, and security is not an afterthought but built in, right? And certainly, let's not forget about API first. That's something that you would want to think about and consider upfront as you build your applications. For instance, using facilities or like open APIs and APIs around open APIs to help you with that, right? So this is how doing all these would enable for us to achieve what we were talking about earlier in terms of really having good cloud native deployments that makes it easier for us to do rapid innovations and then rapidly deploy and to be able to scale up or even down, right, depending on traffic or needs, and also to response for instance, you have a peak loads, then you can scale up easily, and then if you're less load, then you can even scale down to 0 these days with serverless, right? So, and then your services themselves will loosely coupled, and overall you would have a resilient and robust environment that is really easily observable or can be maintained in an easy manner, right? So these are what conceptually what 12 factors and the new 15 factors will enable us to help us think about and consider as we look to build cloud native applications, right? So that's what we want to look at today, and not only conceptually but also in hands-on manner, in the time that we have, how we can achieve these, or some of these actually, the new the 3 factors were in the 3 new factors and 15 factors in a bit of a hands-on manner. So now let's switch our gears a bit to look at some of the technologies that can help enable us to achieve that, right? Especially in the open source sense and in the Java space, right? So that's what we'll focus on, and we'll be using these technologies in a hands-on manner in a bit. So let's take a look at Jakarta EE first. Jakarta EE is a community effort under the Eclipse Foundation, right? You can go to jakarta.ee to find out more about it, right? So it's basically a community effort, different community members, jocks, industry vendors, industry practitioners coming together to try to evolve and come up with the next set of open source cloud native Java APIs for Java developers to use, right? So it started with Java EE being moved under Eclipse Foundation, and then the community has been busy at work since then, right? Coming up with moving things forward to modernize, simplify, and bring in the latest innovations when it comes to Java APIs for enterprises for doing cloud native Java applications, right? It's community driven, right? It's a very open collaborative approach to things. So open discussions, and then and many players are involved. For instance, you can see all the different members of the Jakarta EE working group here, right? So as I mentioned, it comes from all walks of life, if you will, right? Different companies from different regions in the world, and then Java groups from different places participating and contributing, and also including individual contributing members, right, from different SMEs in the Java space. It's really about coming up with bringing the latest innovations to enterprise Java, especially for cloud native Java, and then simplifying what we have, moving things forward, and doing that together as a community, right? And through an open process. And everyone is invited to join in, right, depending on what you need, whether it's trying to use the frameworks or runtimes that supports Jakarta EE, or even if you're interested in contributing your knowledge, your expertise in evolving the APIs, you're more than welcome to participate, and everyone is invited to join in. So these are some of the examples of what's available that supports Jakarta EE, right? So we have many different frameworks and runtimes that support Jakarta EE. You can find out all that has all the frameworks and runtimes that have demonstrated compatibility at the link there, right? And as I mentioned, the community has been busy at work, right, since Jakarta EE came about with the release of Jakarta EE 8 to 9, which is a major one that we'll touch on in a bit more. And then Jakarta 9.1 to the latest Jakarta EE 10, right? So and these different releases are supported by different runtimes. So you have flexibility of choices here, and yet you are using one set of Java APIs that's been defined and collaboratively that reflects the latest what the industry thinks as what we need, right? So Jakarta EE 9 and 9.1 is the major release where we move over from Java X namespace to the Jakarta namespace, right? So enabling Jakarta to truly evolve on its own. So because Jakarta EE came about from Java EE being moved over to Eclipse Foundation, right? So Jakarta EE 9 is the release where everything becomes Jakarta, and then things that's moved forward under Jakarta since then, right? So that's the key thing, right? So instead of the Java X namespace, we are working with Jakarta namespace now for all the APIs, and it's really trying to set the community up for innovations at a faster pace, right? And evolving things under the Jakarta umbrella, and to help the community and the users to move along too, right? So then the latest version for Jakarta that we have is Jakarta EE 10, right? This was released not too long ago. There has been different specifications or APIs that have been updated, and then cleanup being done, right? And then the main thing with Jakarta EE 10, one of the main things with Jakarta EE 10 is the introduction of the core profile, Jakarta EE core profile. It's a lighter set of APIs that the frameworks or runtimes can support that makes it easier to build certain applications, right? Certain type of applications. So that said, but the rest of the APIs in terms of the platform is there for the full Jakarta EE set of specifications, right? So it has all the APIs that you may need. One, to build obviously modern cloud native Java applications, right? Whether it's microservices or other sorts of cloud native Java applications. Two, all the APIs that you may need to interact with to access your backend systems in your enterprises, right? So these are still there, and then the community and Jakarta EE is also moving forward to the next one, which is Jakarta EE 11, and you all can and just easily go search and find out more about where things are heading. Just go on and search, and there are information out there that's readily available. So that's briefly Jakarta EE. The other thing that we'll want to touch on is MicroProfile. MicroProfile came about again as a community effort, looking at how to optimize Java for microservices, right? It's about what sort of APIs that you may need that we should offer as a community, right? In an open and collaborative manner to Java developers to use to build microservices, right? So you can find out more about it at microprofile.io, right? And many similar to Jakarta EE, it's a community effort, right? So again, there are many it's a community of individuals, different vendors, organizations, including Java user groups that coming together to collaborate and define this sort of open set of Java APIs that we need to build Java microservices, right? So how to make it easier to use open Java APIs to build microservices. And then again, many different vendors participate in it, right? Companies and groups. These are examples here, and similarly, multiple frameworks and runtime support MicroProfile too, right? So you have options again. So you would code to one API, right? Depending on what you need, you say MicroProfile Health to MicroProfile Open API or whatnot. Then it will work the same across the different runtimes that have certified for compatibility, right? So the latest release of MicroProfile is MicroProfile 6. And there is a core set of profile, the core MicroProfile platform, right? And actually, the MicroProfile 6 goes along with Jakarta EE 10 core profile too. As you can see, building on top of the Jakarta EE 10 core profile, MicroProfile introduces additional APIs to help us to deal with different aspects that we need to look at and consider for microservices, right? Mapping to the 15 and 12 factors that we talked about earlier. For instance, telemetry is an example, right? Making it easier for you to have telemetry for your microservices, telemetry metrics go along with that, and then doing open API, right? And JWT authentication for doing for securing your microservices using JWT tokens, and fault tolerance and health checks. These things would come together to make it easier for you to build observable microservices and also fault-tolerant microservices, right? So these are examples of the APIs available through MicroProfile. And then there's also, besides the core set of APIs, there's also a different set of standalone APIs that the MicroProfile community has been working on, right? For different types of cloud-native application architectures, right? Whether it's reactive architectures or reactive applications or long-running services, or including GraphQL and things like that, right? So there is a core set of MicroProfile APIs that developers can use that's targeted really around what you must and should have for microservices. And then there's additional standalone APIs for different architecture or application styles for different applications that you may want to build. So that's MicroProfile, and again, these been evolving and trying to bring developers the latest that the community has when it comes to APIs for building one, cloud native Java applications for enterprises, and two, microservices, right? So, and OpenLiberty is one of the frameworks that support Jakarta EE and MicroProfile. Right. In fact, it's the first production-ready runtime to support both Jakarta EE 10 and MicroProfile 6, right, earlier this year. And both Rich and I work on OpenLiberty, but it's an open source framework, cloud native Java framework, and that's what we're going to use today in our hands-on exercise or labs. So we'll quickly touch a bit about it, so you have a background about it. It's an open source project, right? So you can find out more about it on openliberty.io, or if you want to look at the code and interact with our development team directly, including us here. So you can go to github.com/openliberty. You can find everything there. It's really a lightweight framework, right? Looking to enable developers to build and deploy microservices, cloud native Java applications in easier manner, right? It has different capabilities and unique architecture that's good for cloud native Java applications, right? It's a really lightweight, composable runtime. So you only need to work with what you want. So if you have a simple RESTful services that you can just simply use to get what you need for that and run things in a very lightweight, easy manner. And then it supports zero migration, so you don't have to change your code or your configuration as you move up your underlying framework runtime, right? And then it supports all sorts of APIs from Jakarta EE to Java EE MicroProfile and also Spring Boot. So you have flexibility working with runtime to run different sorts of Java applications that are using different APIs, right? So, and it's also a cloud-ready framework, right? So, and it has different tools to make it easier for developers to build your applications too, right? So from a starter, that makes it easier for you to get a template project created to build your application, to a dev mode, that makes it easier for you to just focus on your code, and then we'll handle the rest for you, right? So as soon as you launch into dev mode, right, we'll monitor any changes that you have for your applications, and you don't have to, as soon as you save, then we'll pick up the changes, compile and deploy for you to make it easier for you to do iterative development. You may see some of that in action as we work through the labs for 12-factor or 15 factors today, right? And then also Liberty has different tools for the different IDEs, VS Code, Eclipse IDE, IntelliJ, for you to work with Liberty in your IDE of choice, right? So just quickly, a brief introduction to Liberty. Besides that, obviously, Jakarta EE and MicroProfile as the APIs to consider to know about for cloud native Java applications. And now let's switch gears and look at the labs and get into the hands-on portion.
Yeah, so I'll take over now. Go ahead and drive the slides, YK. So today we're going to be getting hands-on experience with our skills network, which is a really valuable tool, I think. A lot of developers really like this. gives you a chance to play with different technologies that we talked about today. It does require, so there's two ways to run our workshops. You can run them locally, or you can run them on the cloud. And we're going to run them on the cloud today. It's a lot easier. When you run it locally, you have to download a lot of the prerequisites to get it running, including an IDE, probably Maven, Docker if you are running containers. But if you run in the cloud, everything's going to be provided for you. You're going to just go straight to the environment. Everything's going to be there for you, and you can just run. So we'll require a single sign-on account. If you go back real quick, so hopefully everyone has one of these types of accounts. So GitHub, Google, or LinkedIn will all work. Okay, next slide. This is a picture of what your environment's going to look like. You're going to have instructions on the left, which you can navigate through, and then an IDE on the right. And you can have actions take place on the left that will affect the code on the right. So it's a really cool environment. As you scroll through, you'll get different good information that you should definitely take time to read through, not just clicking the buttons to make the lab complete, but understand what you're trying to do and what it's taking you through the steps. Next slide. So today we're going to be doing, I think, three labs, YK, at least two. And they're all based on this theory of this two microservices, which are system and inventory. So just keep that in mind. They're all kind of similar in that they're educating you on different features, but the base applications are usually based on two microservices, system and inventory. Next. So this is what you're going to see if you go to openliberty.io/guides. You'll see a list of the different technologies or features on the left. I think we're up over 60 different guides available, all of them ranging from 15 minutes to 30 minutes. So they're really, they get right to it, and they don't take a long amount of time. So I think it's really a great way to learn different features that YK has already discussed today. Go ahead. So lab one we're going to be doing is on documenting RESTful APIs, which I'll get to in a second. Go ahead. Let's talk about this a little bit. Lab environment you already know about. So we're going to talk about API first. So API first turned up in YK's list of the 15 factors. So again, API first is just making APIs a first-class citizen, meaning you think about them and design them up front. You get feedback from the producer of the API and also the consumers of the API. You define a context or a contract that you can both design and implement independent of each other, knowing that contract is going to go forward. This is what the API is going to do. This is how I call it. This is what it's going to return. So that's the theory behind API first. Next slide. So there's a couple of technologies that help you implement and annotate and get them set up in a standard way. And one of those is MicroProfile Open API, which we'll be using in this lab. Next slide. I think that's me. Let me go ahead and bring up my screen now. I'm going to share. Okay. Whoops. Lost it. Sorry. Can everyone see that?
Yep.
YK, can you see that?
Yes.
That's okay.
All
right. So here's that. Here's the link.
For everyone, feel free to maximize your screen if you want to see a bigger version of what Rich is sharing. Feel free to do that. I think the conference platform allows for us to maximize the screen that we are seeing.
Yes, I've maximized mine. So if yours looks a little small, please maximize yours. I can go a little bit bigger. Hopefully that's better. As I mentioned earlier, this is the openliberty.io /guides link, which everyone should go to. Again, we have the technologies or features on the left that you can learn about, and the associated guides on your right. And you can see a lot of them are available to run in the cloud. Not all of them, but most of them. As I mentioned, if you run it locally, you have to download your own or satisfy the prerequisites. But if you run in the cloud, everything is there for you. If you click on that, well, first of all, we're going to find getting, where is it? Documenting RESTful APIs. If everyone could find that. Let me see if that shows up. Yeah, if you click on the left RESTful service, it should limit the amount of options you have, and there should be a documenting RESTful APIs. It says it should take about 20 minutes. Now at this point, you can go ahead and click Run in the Cloud, and it's going to bring you to that login screen. Or it may take you here. I'm not sure of the exact order, but we run it in the cloud, then it's going to take you to this sign-in screen here. So I'll go ahead and wait. I'll give everyone a couple minutes to do that. Again, we're at OpenLiberty.io/guides, RESTful service, documenting RESTful APIs. And we're going to click Run in the Cloud. Now, once you sign in, it'll move you to the cloud and it'll start running and it'll be loading it. And it could take another minute or so. It'll spin for a bit, loading the environment. Every person here who's going to try it gets their own environment on the IBM Cloud. So eventually you should come to a screen similar to this. YK, can you monitor? Maybe we can ask everyone to raise their hand if they're at this point.
Yep, I'm posting the link to the lab directly too, because there is a question about that.
Okay.
It looks like I think we are good. At least I'm seeing some feedback where users are there.
So again, the instructions are on the left side. There's a couple of features here, or helper functions. There's a little right arrow underscore. So if it asks you to do a command, you can actually click that and it'll move that and it'll execute that command in your terminal window, in your IDE. There's also a cut-in or a copy that you can then go here and paste in, but this is a lot simpler. It's just to click the greater than underscore. In this particular lab, we ask you to go get clone a GitHub repository. I'm going to go ahead and I'd like everyone to run this on their own pace, but I'll go ahead and run it on this screen in the background. So maybe you look up, you'll see that I'm at a certain point where you are maybe, and maybe I can help you out, or, but feel free to ask questions in the chat if you run into any problems at all. But I'll go ahead and run through this lab at the same time so we get a feel for how long it's going to take. The other comment I want to make, I've done a lot of these workshops and people run into this problem. Whenever they give you some code to insert into a file, it's always better to copy all the code and paste into and replace the file contents. Don't try to find the exact line that was changed and then try to find it and insert it. Just go ahead and do a mass cut, then do a Control A to copy everything, and then just paste over it. Also, when you're running in dev mode, it automatically detects any changes to any files and it'll restart the server on the back end, so you don't have to stop and start any of your the application server. what you'll find is you're doing this, you're just adding more and more annotations to the REST APIs. How is everyone doing? I saw a thumbs up. Good. Everyone liking the environment? There we go. It is really cool, especially running on the cloud where you don't have to download anything to your machine, your system. And it usually works very well. What do you think, YK? Another couple minutes?
Yeah, I think so.
Another maybe 4 more minutes till at
Yeah.
least my clock will be 55.
Mm-hmm.
And then we'll move forward.
Yeah, sounds good to me.
me go ahead and clean up my environment. I'll go ahead and stop sharing.
Hopefully everyone has been able to follow along, and you can see how, I mean, obviously besides the cloud host environment for the lab itself, you can see how actually with the modern APIs that's been defined, like MicroProfile Open API and what it provides, right, supported by the different runtimes and frameworks, including OpenLiberty, it's pretty straightforward for developers to actually work with Open API and then think about and work with applications in an API first manner, right? So the different ways to do that, you can do it from within your code, or you can do it from an API document. It's doable, right? But really, when it comes to how you would work with Open API, it's really easy with MicroProfile API using the different annotations that are provided. And hopefully you see that in the last 25 minutes or so using the exercise, right? So let us know if you have any questions or feedback anytime, and we'll be glad to chat, right? So as today, I mean, we'll focus on 2 or if not 3 labs given the time we have, right? Focusing on what's most directly relevant for the 15 factors, especially the 3 new factors that we were discussing earlier. But when it comes to all these exercises or labs under openliberty.io/guides, openliberty.io/guides, they're always available out there, and they are available open source for free, and including the cloud hosted environment. So if you want to work with it offline on your own machines, you can, right? You just clone from the repos that we provide, and then you can work on it, use it on your own machine if you like, or if you prefer to use the cloud hosted environments, they're always there too. So now let's continue if we are good to proceed. So I think we are still doing good with time, so that's awesome. Thank you to you all here. And we talk about Open API. The next lab we'll look at is mapping to the telemetry factor, right? So, and actually the next 2 labs, right, depending on how much time we have, or we'll do both, or we'll cover both. Otherwise, in any case, they map to the telemetry factor. So telemetry is really having the ability to understand and observe and see what's going on with your application or applications, especially in the deployed environments, right? In where they are deployed, right? So you need and want to be able to understand what is going on so you can effectively maintain and service and support, especially should issues come up, right? So, or when you need to take actions, right? It's really achieving that degree of understanding, observability of what's happening, especially not only about the environment, also within the application itself too. And there are different aspects to it. One is around knowing at I guess at it's not so much high level, but at getting a quick pulse or sense of whether your application is alive, it's healthy, it's running, or actions need to be taken to restart it, to kill it and restart it and bring it back up, or it's not ready to take requests yet, right? So that's where health check comes in, and that's what we'll focus on here. But then besides knowing, having a sense or pulse of how your applications is doing, there's also the notion of understanding what's actually is it's running, right? For instance, having a notion of how many times, for instance, counting or determining or tracking how many times a certain API has been accessed, or being able to trace two things, right? There's aspects of metrics about the system, metrics about your application, and also tracing through your distributed environment with your applications included, right? So that there are these aspects, and we'll look at health check in this next lab, right? And some of the common tools or names that you may have heard of would be, for instance, Grafana as a dashboard to view what's going on, right? So that's the dashboarding. Open telemetry as a sort of a defined way to deal with telemetry, right? And then micrometer would be a common one, right? So or even Kibana or other things, or Logstash and things like that for getting data and so on and so forth, right? So these are some of the things here, but our focus today would be on for this lab actually would be from a Java perspective, using microprofile health check to see how we can easily be able to have the application report on how it is doing, right? Basically providing health reports to any probes from the environment that would be interested in checking if your applications are doing fine or not, and then to take corresponding actions, right? So this can be a Kubernetes orchestrator or some sort of cloud orchestrator trying to understand whether your application is alive, it has started, or it's ready to take requests, right? So that's what the health check is about, and trying to enable that and users to do that easily using a microprofile, using Java APIs, and in this case would be through microprofile health check. So I will, let's see, we will post the link, and then the lab would be this microprofile health lab, and I will take you all to follow along here. Let me switch to my... Yeah, if Rich, you wouldn't mind posting the link so everyone can get access to it.
I was going to do the lab. Do you want to do the lab?
I can do the lab, and then you can...
okay.
You want me to...
I'll post the link.
Yeah, I'll give you a break. I have enough of a break. I'll do this one, and then if you wouldn't mind taking it the next one, if we have time, then that's awesome. All right. Okay.
I'm getting there. Sorry.
So I think everyone can see my screen share. Yeah, we encourage that you work in full screen mode, and I try to make it bigger. I think it's fine here. So the guides, they have running cloud options. We mentioned it already. This health check is under observability, so there are other things here, but this is the one that we're looking at as the second lab, right? So adding health reports to your microservices obviously this Java microservices here, right? So I already have it started because I booted it up already. And you'll see this cloud hosted environment. I'll try to make it a bit bigger. Hopefully this is good. I mean, you can use the A plus, A minus to adjust this one if you like, but it works the same if you use your browser to zoom in and zoom out, right? It will actually zoom in and zoom out your the cloud IDE too. So this is actually a cloud IDE that the IBM Skills Network environment provides. So yeah, so this is really running in cloud and
The link's
yeah.
been posted, by the way, just
Okay.
let everyone know.
Yeah, so if you will join that, and the login mechanism is the same. You just run in cloud, and then when I click on it, it doesn't do anything because I'm already logged in, but you'll get that either you use your single sign-on to follow along, I mean to sign in, or you can create a new account if you want, but assuming everyone actually has logged in using your single sign-on, so that works. And then you'll be brought to this environment here with the instructions on the left, and then the cloud ID on the right. So this is about adding health checks to your microservices and enabling your microservices to report on how it is doing, right? So the way the lab is set up, or the guides in general, is that you will be asked to try through things to see how things will work first before you actually go about doing it or messing with the code, right? So in this lab, again, we'll be working with the inventory and system services, right? There are two services, and then we'll be adding different health check, enabling the microservices to respond to different health checks, right? By providing health check responses to essentially indicate whether it's up or down or whether it's available. And there are different types of health check reports or health checks that typically that you may need to be concerned with, right, in a cloud environment. Startup, liveness, and readiness. Startup basically means whether you have started up fine or you need more time to start up, right? So if someone comes in and asks that question, you let them know whether you have started up or not. Liveness means whether you're alive or not, or whether you are really needing help, right? Or they should actually take you down and then restart, right? Liveness, whether you're alive or not. Readiness means maps to whether you're ready to take traffic, for traffic to be routed to your services, right? So as you can see, these different health checks maps to what do you call how a cloud orchestrator might need the information to make different decisions as to how your services are doing, right? So, okay, so then as Rich was doing, we would start with get started to get things set up. I already actually cloned, so I don't need to clone again. So I was cloning it moments ago. It's already there. We provide these repositories with the code, so you can work with it for the lab, or you can look at it anytime, right? So, and then we'll try out what we will be building first. So we are starting the application, right? So this is actually, because this is a brand new environment, so everything is being set up for the first time. So it will be downloading. It's actually downloading from Maven Central and everything, the different artifacts that might be needed. Okay, so it's there. We've started the application running on top of Liberty, and I'll bring in a new terminal, and then we'll try things out. So this is, I'll try to expand this. This is testing the system service. Yeah. So it works, and then we are going to test the inventory service. Again, this is fine. The inventory service basically tracks how many systems you have. And so next it's actually going to ask you to check or access to query the different health check endpoints. As you can see, this is sort of a top level check. Everything is up for the different types of health checks. And then I think it's going to ask you to go drill down to different types of checks that we have, right? This is the startup one. And then this is the liveness one. And this is the readiness one. So as you can see, it's really just trying to give you a sense of what you're building, right? The different type of health checks and how you would be able to query these endpoints for the health statuses of your application or microservices. And this would be what, for instance, Kubernetes will use, right? You can configure Kubernetes to probe these endpoints to get these information, or whatever cloud orchestrator that you may be working with. So we'll be stopping the running instance here. And the try here is actually using the code under finish. If you haven't noticed that, finish as the completed application. When we move on to try to build the different things with code, we'll be using the start. We'll be using hopefully everyone can follow along, and I'll just go ahead, right? So and take your time, right? So we're just trying to go along with all of you, or do it at the same time as all of you are doing it. Don't worry if you need more time or less. So that's all good. And let us know anytime you have any questions or concerns or feedback. Okay, so for what we have here, we'll be building these, or actually adding these health check reports to the microservices we have here. So that will be the inventory and system. So launch deliberately in dev mode. Dev mode is what we have to make it easier for developers to work with the code, where we try to take away the mundane tasks from you, so you don't have to worry about recompiling, deploying stuff again, and so on. So that as soon as you make a code change and save, we will pick that up and make it live for you. So it's setting up things for the first time, and we started. So I'll just go ahead. Okay. I mean, you can browse for all the code here if you like, right? You can see this is the start folder with all the different. That's what we're working with to build a new code, or write a new code. The finish folder was what we were working with to try out the finished application, right? You can work with this, but the guides, the labs themselves are designed so that it can be done in an easier manner. So it's the commands are all there, so you can follow along or just run in cloud easily. But if you want to browse around with the different things, you can. That's not a problem. So we have a new Java classes created. This is a startup check for system. We'll open it up. Right. And then as the tip that Rich offered, copy the whole file and paste it, right? And that's easiest to work with because in these environments, workshops, when we do things live, we want to make it easier, make sure everyone can come along. So the easiest approach is to actually copy and paste, right? I mean, obviously we can go through the code and we can touch on it, cover it, but for the sake of running the labs, that's the easiest way to do it. So as you can see, actually, when I save this, the Cloud ID is set up to save the file already, and actually this new class has been picked up by DevMo already. It's actually compiled, so we don't have to actually do anything. We can just test right away, but that's not what we need to worry about now. We'll be testing it in a bit. So this is the new health check, startup check for the system service. It's basically just checking for memory or CPU usage. I mean, this is a fake one, right? Or simulated one, I should say. So if saying that if the CPU is busy, then I've not started up yet, right? So in real life, you would want to see what makes sense for your microservices and do the corresponding check here and provide the right response, right? Just continue. It's just going to take us through creating a different checks, health checks. So this is the liveness check. And then it's doing a simulation on checking for memory usage. And the third one is a readiness check. So it's the lab is going to ask us to do the same for inventory. The idea is more or less the same, right? It's just doing different. As you can see, the code is pretty straightforward. There are different annotations that you use, right, and interface that you would implement that would give you give you what you need to do to instrument your microservices with a health check response, right? So just this is a readiness and the annotation for readiness check. You implement the health check interface that we're getting from microservice. So that's really it. So hopefully everyone is coming along fine. If you have any questions, let us know. Raise hand. What is the best? I think so. There is a question from Rima regarding cloud infrastructure service. I guess I would want to. I mean, if you can elaborate by what you mean by cloud infrastructure service, that would be good. But I would say I guess there are many cloud options these days out there, and they are. Other than the fact that they are by different companies, what they offer is kind of similar in a sense. They would offer similar kind of services to you. So it's really a matter of personal preference, right? So, and then it's about you trying things out. I mean, the typical or the well-known vendors are out there. They would give you similar kind of things, whether it's say working with Kubernetes or working with containers or working with VMs even, right? They all have those options, and then they typically would offer you a free trial, so for you to start with, to play around with, right? At the end of the day, it really comes down to depending on whether you're working with a company, and then you would consider what would make sense from that standpoint for a company or your business requirements, or if you are just as an individual trying to pick up on different things, I would say that they are the same, similar, I should say. And then it's more of what you like and what's available for you, right? So.
Yeah, trial accounts are real important to find those. You want to learn as much as you can for free before you have to pay money for stuff.
I think there's another question. Obviously, I think we'll need to better understand. I think we'll need to better understand what we mean by associate level. But then, I think getting some services or application running in the cloud is typically fine, right? REST service and trying to work through something, deploying it in a cloud environment. I think that will be the starting point. And there are different types of applications that you can work through. And there are different examples out there, right? You would want to even start by replicating that in a cloud environment. I think that would be good starting points for you to consider.
There's a question on hours. Yeah. You can
Yeah,
go
for
ahead
the cloud, yeah, for the cloud hosted environments, it's on. I mean, there's a timeout, right? I think if there's an activity for, say, I think maybe 20, 30 minutes, it will take it down for you, because obviously IBM is paying for these resources. But you can come back in and use it again, right? So there's no limit in that sense. You can always go back in and use it. But if you stop using it for a while, the system will actually reclaim the resources. I think a rule of thumb is 20, 30 minutes, Rich. Am I right?
I thought it was a little bit longer than that, but that's probably safe. And the worst thing is that you'll have to start over. Yeah. Usually it is Java based. Yes.
Yeah. For what we have here is Java based, because that's what the platform is, and that's what we focus on. Yeah. So. Okay, let me continue. Thank you for these questions and feedback. So I was working through creating all the different health checks that the lab is asking us to do. Now there's a bit of a special one for the inventory readiness check, because there's a bit more code. We will see why it is the case later on, because it's trying to do a simulation where you can see that actually by changing a configuration parameter, we will change the readiness response to become down from up, right? So there's a code here to simulate whether this service may be in maintenance mode or not, right? So this is a bit of a special one. The rest is more or less the same in terms of idea or concept, right? So I think I finished creating all the code, right? Finger crossed, and then with dev mode, everything should be all set up and going already. Then I'll see if I can run and test these response. So the first one is fine. So they all come back. So this is the new code that I created. And the second one seems fine. It's just querying different endpoints, right? So okay, I'm just trying out the different endpoints based on what we've created. So then they all are good. Everything that comes back up, which is the idea, because unless something terrible is going on, the CPU usage won't be maxed out. The memory should still be fine, and obviously, even though if this is a test environment, that should be healthy, right? So then the next part here is actually about doing a simulation and see what happens if something goes down, right? So the code is the application is set up to have a configuration parameter, and this is not covered in this lab or this workshop. Actually, MicroProfile has a MicroProfile config API that makes it easier for us to externalize configuration. It's basically, again, a lot of it is annotation injection. And then here we have set it up to have in maintenance mode configuration property, right? The idea here is that we'll change this property to true to indicate that the inventory service is going to be in maintenance. See what happens to the health check response, okay? So originally it's not in maintenance, which is a regular case, right? So we're changing that. That changes pick up already, so we can just go test it out. Oh, I closed my terminal again. That's okay. We'll just do this. And you can see this one as a down, as an overall status, because the inventory resource readiness check is down. So that means our configuration change actually works, because that's what it wants us to do. That's what we want it to do, right? So because the idea is that with this configuration, at least in this sample example here, right? So you change that configuration property to indicate that your service is maintenance and no traffic should be routed to it, right? So then why is it down? But the error is that the service is currently in maintenance, right? So that's the idea. So that works. Then we change it back to the usual case, the regular case where things are not. Now, if I query it again, it should be fine. Yep, it's all clean. So that's what it is. So it's actually pretty straightforward to work with these APIs, even with Java. In fact, Java still is one of a lot of them still widely used, right? In a lot of mission critical deployments. And then the guides themselves, the last part of the labs would be around testing, right? So we try to make sure we cover testing, because that's integral as part of a good application development practice, right? We always want to ensure we test, whether you write your test up front or after, it's the same. And these tests, we can create them up front if we want, but for the benefit of the lab setup, we have them here as the last section. Then we'll write these integration tests for the health checks. So I'll paste the code. If you look through the code, it's basically testing all the different health checks, whether the startup check, the liveness checks, the readiness checks, and also including the maintenance mode simulation that I was working through manually, right? So to test that your health check responses are accurate. So the tests themselves are pretty straightforward. That they are just a reflection of what we would run through to manually validate things, right? But done in a coded manner, so you can easily rerun them all the time. right? Then to rerun the test, to run the test is pretty straightforward because we are running in dev mode. There is a shortcut to do that. In this case, we are definitely set up by taking an enter or return. It will just run tests. We can actually set it up to run tests all the time if you want. But in this case, it's upon an enter, it will run all the tests that you have for your project, for your application here, right? So it's now run the 8 tests and everything passed because everything is fine here. I mean, obviously we can simulate a failure here if we want, but in the interest of time, we don't need to do that. So yeah, I think that's really it for this second module. And I'll stop my environment here. And then I will clean up in a bit, but I'll stop my sharing first. And then we'll see how things are for everyone. Now, going back to the question about cloud projects to try, I would say perhaps a REST service that's backed by a database, right? That's a typical scenario that one may work with regardless of language, right? Or Java being a common one, right? You can always build front ends if you want, but from a enterprise standpoint, right, you would have a bunch of services that would access data in a database. And your database can be SQL or NoSQL, whatnot. I think that would be a typical application that you can look at and try to do, right? And then you can get fancier from there on. So hopefully that helps. Okay, so Rich, do you feel like we should move on to the third one, or?
I'm thinking they know how to get access to it. I think we give them another 5 minutes to finish that one up, and then we do the wrap up, and then
Okay, yeah,
I think
that works.
That way we're not squeezed at the end. I think they know where to access it, and they can come
Right.
back to it anytime.
Yep. Great.
Maybe you can share the slides again so we're not staring at us.
Yep, I will do that. Let me do that. I definitely should. So we finish up the health check ones, and then there's I guess the one that goes along with it is the metrics one. The idea is the same, right? So, and the guides are always there, so you can always go in and do this one or more, right? So you can try out. This will give us the metrics view of how you would provide system and application level metrics, right? So then there's also a JWT one, right? We cover the three new factors, right? One being telemetry, one being API first. Rich covered the API first lab. I touched on one aspect of telemetry with health checks. Metrics is the other one. And then obviously there's also tracing, right? So so you all are welcome to try out the metrics one at your own pace or at your own time. And then there's also the GWT one, or authentication and authorization. Obviously, that there is a bigger topic in general, but MicroProfile has MicroProfile GWT API that makes it easier for you to secure your microservices using JWT with JWT tokens, right? So,
right. Yeah, maybe bring up the guides list again. Just yeah, there you go. These are some good ones that we recommend that are kind of related to what we talked about today. Notice all of them can be run in the cloud, and they're all 15 to 25 minutes. So
There's a question about what do we expect from cloud technology in the next 5 years. Hey, AI is the big thing, right? Well, that's going to be one of the things to keep in mind, even from a cloud standpoint, because that's going to change. I mean, it's not change. It's going to have a significant impact as to how things will be done and be looked at, and that's why the conference is decoding AI as a theme, right? I think that's really exciting and good. That aside, I think Kubernetes is becoming pretty much the common platform now, right? So and then making it's becoming a lot easier for people to work with it, with a lot of abstraction around how you may work with Kubernetes, so that you don't even have to worry about some of the lower level stuff, right? So containers, Kubernetes are essentially becoming mainstream, if not mainstream already, depending on who you talk to, right? And AI is going to be important. Kubernetes container-based deployments. Other than that, I think going back to the earlier question about which cloud is the one to consider, I think they are becoming similar to an extent, other than how much you need to pay. If you see what I mean, on how easy you can access it from where you are and whatnot, it starts to feel like it's a bit of a commodity. And in fact, that makes sense too, right? From a business standpoint, a lot of it is about scale. So it's going to be common for us to work with that, work with clouds, whether it's public, private, or wherever you want it to be, right? And I think the fact that it's going, the fact open source and being able to work with what is open is going to be key for developers and for companies alike, right? That has been the trend, and that continues to be the case even with AI, right? So you want to look at how to work with it, even cloud technologies that's open, that won't lock you in, whether it's with the APIs or even the deployment technologies, including even AI models, right? So that's going to be something to pay attention to. That's my thoughts. I don't know if Rich, you want to add anything.
No, I would agree. The abstraction part, I think it's going to get a lot easier. They're going to add more layers. It's going to make it easier to use more complex tools so that everyone can use it. I definitely think that's the way to go. And I think that the model toward serverless, which is more of a pricing model where people are going to say, I only want to spend what I'm using. And
Mhm.
if no one's accessing anything, I don't want to be charged. So they're all going to go to that serverless model, I think, more and more. That makes sense. But abstraction is going to be a key. And you're right. Every platform basically has the same functionality. They call it different things. It's priced differently.
Right.
So when someone had a question, I didn't even see that question. I don't know where you're looking, but there is another question about Jakarta WebSockets.
Yeah, we do support that.
Yeah.
OpenLiberty supports WebSocket, so that's not that's there.
Is there an actual lab on that?
I believe so. Yeah.
Yeah, I think there's a specific lab on that.
Yeah, if you go back to the OpenLiberty/guides, openliberty.io/guides, under REST alternatives as a category, you'll see a guide for Jakarta WebSockets, and also OpenLiberty supports gRPC as well, if you want to work with gRPC. So, I mean, obviously there's other things like GraphQL and so on, but that's for a different purpose, right? So yeah, to answer that question, WebSocket is supported both as a Jakarta spec as well as obviously by extension in Liberty, right? So.
Any more questions before we wrap this up? Maybe we'll go through the wrap up now and then use some questions for the end.
Sure.
Did you want me to cover the wrap up?
Yeah, go ahead. Go ahead.
Let's see. I'll read through that summary. So we learned about the 12-factor applications and the importance of that. So basically, a group of people decided this is what you need to be successful with cloud native running on cloud. Over the years, we added some additional factors which are really important. The biggest one is probably security. That should have been in there to begin with. API first and telemetry, which we touched on a little bit with our lab today. So no excuses, lots of open source tools. So everything we discussed today, Jakarta EE, MicroProfile, even OpenLiberty, all open source tools available, free to download, free to test, free to run. You should always evaluate your own applications against these 15 factors if you want to be truly cloud native and take advantage and work properly in the cloud. Next slide. So we have a lot of useful resources, links to different blogs. So you notice there's a couple different places. OpenLiberty.io has a nice blog site with a lot of great articles, including the one about the 12 factors. We also have IBM Developer, which is under developer.ibm.com. There we have a number of articles, blogs, tutorials, a lot of really good information. We're pointing you to specific places regarding the talks we have, but there's tons of topics in there and subjects that are covered. Again, OpenLiberty. We want to point to this GitHub OpenLiberty Deep Dive, which is so we developed a guide that incorporates almost all of the features into one. And it takes about 2 hours to complete. That is the right one, right, YK? That's what that is? Yeah. And we've actually done some workshops on just using that one, which touches on the three we talked about today and also security and all sorts of things. So if you really feel like going deep, you can take your chance at that one or take a look at that one. Next slide. Links to materials again. They have access to these slides.
We can share them.
I think they will. Okay, so these are all good places to go to get more information. Again, OpenLiberty.io is a great website. There's also MicroProfile.io. Some at the end there, we talk about test containers, which we didn't discuss today, which is very important, and the Jakarta EE homepage at the end. Again, all this open source. Next. So reach out to us. We have a LinkedIn account and a Twitter account, both related. It's all about Open Liberty. You can get the latest on updates, and we sound out information about different topics we cover with I don't know, different assets. Do we have the cabs anymore, or YK? What are we doing with that? What kind of things do we advertise in Open Liberty?
We actually, I mean, we'll post about the latest that we have, and in terms of resources or the latest innovations or enhancements that we're delivering, and also if we will be speaking about different topics, right? So
yep. So that's how you keep track of what's going on.
Yeah, and yeah, I mean, feel free to connect with us directly too if you want, right? Whether it's Rich or myself, besides obviously reaching out through or connecting with Open Liberty IO, right? So
yeah, definitely reach out to us. We're on LinkedIn and Twitter.
Yeah, that's really it.
Yep.
So let's see if we have any other questions or any feedback. If you have any other questions or feedback, let us know. Don't hesitate now or later.
Yep. You can reach out to us privately too.
And again, the labs themselves, while we will walk through two main ones today, they're always available there. You can go back in anytime. And yeah, they're also open source, so we welcome your contributions even.
I think we have one final question, sir. Mar De La Torre is asking, how will we be able to access the slides?
Yeah, we'll be glad to share them. I don't know if the conference has a place for resources to be shared. We can share your.
Yes, we actually have the resources tab where the speakers can actually upload the resources.
Yeah, I'll do that. We'll do that.
All right.
Yeah.
So guys, Sir Yi Kang will be uploading the materials that they presented. And
Sure.
yeah, so thank you, Mar. And once again, thank you so much, Sir Yi Kang and Sir Rich, for answering all their questions and, of course, your presentation this morning. Guys, can we show them our appreciation by showering them with emojis?
Nice.
And of course, like Sir Yi Kang and Sir
It's a
Rich
pleasure.
said, in case you guys still have questions or want to reach out to them, you can actually chat them here on AirMeet, or you can reach out to them through their personal channels, the one they shared earlier. And I think that's all the time we have for this session. Once again, thank you so much, Sir Yi Kang Chang and Sir Rich Haggerty, for being with us this morning and for sharing your expertise with our attendees this morning. Once
It was a
again,
pleasure.
let's give our appreciation by showering them with emojis. And
Thank you.
guys, that's all for this session. Please, you may now exit this session and enjoy your lunch before we come back at around past 1. I think the next session is starts at 1:10 to 1:30. So please enjoy your lunch as of this moment, and we'll be back after lunch. Bye.
Bye-bye.
Thanks, everyone. Glad to be
Thank you.
here. Bye.
Thank you so much, sir.